I would do it differently. What I got here is molten zinc ingot directly on my stove surface, which is a bad idea, but I did it this way, because I was not sure if the stove could deliver 420 degrees to the zinc trough the pot, but as I found out it can. Okay, those are just the details. What is important is the overall The idea is to melt the zinc and keep it moving in any way while it solidifies. There is a temperature near the melting point when zinc becomes brittle. You can see what I am trying to do here, melting, shaking, and sieving off the large chunks. I tried to use a mixer to keep it moving. This actually worked fine. Here you can see the mistake I made. I was in a rush, so I cooled the stove with water. Normally it would be fine, but because there is a layer of zinc in the top, heat transferred way too fast and ceramic surface could not withstand the thermal shock and cracked a bit. Anyway, after cleaning up the mess with acids here, I have a large pot of zinc sand. I let it through 0.1mm mesh and separated the large pieces. The large pieces was then milled in a coffee mill and sieved again. You can see the powder with finer mesh, but I don't have one, so I stop here. About 70% of zinc was chopped to particles finer than 0.1mm. This powder is useful in chemistry and even work with pyrotechnics, and is much easier to ball mill if finer powder is needed. Last thing to do is put the powder in a container and store it for later use. That's all. I hope you find this useful. Thank you for watching. Like and
liters of water and etch with 130 grams of zinc hydroxide. Stir until it dissolves. Now add zinc oxide until it stops dissolving. I add about 40 grams in two 20-gram portions. Zinc oxide can easily be bought from pottery supply companies and soap making suppliers. What's happening is the zinc oxide is reacting with sodium hydroxide to form sodium zincate. Now I'm going to let the mixture stand overnight and settle and decant off the clear solution. I tried filtering it, but my zinc oxide was so fine that it passed right through. Anyway, here we are with the decanted clear solution of sodium zincate. Now we insert our electrodes. For the positive terminal or anode, I'm going to use nickel strips. The great thing about this alkaline zincate process is that it's not as corrosive as acidic processes. Thus, it can use cheaper and easier to obtain nickel electrodes rather than expensive platinum or toxic lead dioxide electrodes. For the negative terminal or cathode, I'm going to use this copper circuit board. The zinc plate would be better, but I didn't have one. Once both electrodes are in, raise the current until the cathode just starts to bubble, then dial back about 20% or so until it stops. We want the zinc to come out and not hydrogen. What's happening is that at the cathode, the zincate ions are being reduced to zinc metal as well as hydroxide. At the anode, the hydroxide ions are oxidized to oxygen. Overall, we're converting sodium zincate into sodium hydroxide, zinc metal, and oxygen. Now, sodium hydroxide was what we originally used to dissolve the zinc oxide, so it's really best behaving as a carrier. What we're essentially doing is splitting zinc oxide. Now, if you look at the zinc surface, you'll notice it has a somewhat sandy texture to it. The crystals of zinc metal produced in this process don't bond very strongly, so rather than a metal plate, we're getting more of a metal sponge that will crumble when we recover it. Anyway, I'm letting this go overnight. And here we are the next day. Let me turn off the current and remove the nickel anode so you can see what we've obtained. So we have a nice thick deposit of zinc. You'll notice that even though we turned off the power and removed the anode, the zinc is still bubbling. This is because we completed the solution of zincate, and now we're left with a concentrate solution of hydroxide. Zinc actually reacts with concentrates of hydroxide to form sodium zincate again in hydrogen gas. Stopping the reaction is easy enough. Remove it from the solution and give the zinc a good wash with water. Now leave it to dry. In the meantime, if you want to make more zinc, just mix the solution of sodium hydroxide and leftover sodium zincate with more zinc oxide and electrolyze again. If you want to make lots of zinc, you don't even have to decant the solution and you can just electrolyze directly. The sodium hydroxide produced will dissolve more zinc oxide and thus keep producing zinc until it's depleted. I just decanted because I want a clear solution to show the chemistry. You don't need to do this. Anyway, back to zinc metal. It's a couple of hours later and the zinc has taken a tarnished appearance because it's reacted with the air to produce a layer of zinc oxide. This is only a surface discoloration and the zinc underneath is still fine. Now just scrape off the zinc. As you can see, it's crumbling into powder. If you need powdered zinc for your chemical reactions, this is a great way to produce it. And there's our powdered zinc. It's a bit damp, you get the point. If you use this for reduction reactions, the metal refiners might want this for displacing other metals from solution, and metal casters might want this as a source of zinc for zinc casting. Now, as I said before, this alkaline zinc process only produces zinc powder. If you want to
What is a ball mill? I'm researching how to make silver particles. How to convert silver bar into powder. Press return. Nope, I got a better way, guys. Check it out. I just figured it out. Alright. Stop listening. Okay. So, we have to turn silver bars or silver shot. I think I ordered it in shot, which are like little pellets. I don't know why it's called silver shot. It's not going to be shot out of a gun, is it? I don't know. I bought silver pellets, and I need to convert those pellets into fine powder. I'm going to try different finenesses and experimenting to see if the finest of the fine powders is better, or coarse powder, or some combination between, for creating conductive silver glue slash paint, to make my own circuit board traces out of silver glue instead of out of copper, which is the normal way. You take copper clad board and you use etching techniques to just remove everything but the copper traces you want to keep. I'm proposing an additive method where you eject silver glue from a surgical needle in order to lay down traces, and then they harden, because it's glue, into an excellent trace that is conductive and everything, and you don't have to use any soldering methods at all to attach your components. You just lay out the components and squeeze out the silver glue through a needle and connect all the components and all the traces on your board just like that. Boom. It's an excellent way to do it, and it's very underused in my opinion. You just don't hear about people doing this. Now, I did buy silver glue. There's really expensive stuff and pretty reasonably priced stuff. The reasonably priced stuff is obviously made in China. But I'm concerned that it won't have enough silver content, so it won't be conductive enough. So I want to be able to create my own silver powder so I can add more silver to the Chinese glue to make it more conductive if it's not conductive enough. Or in addition to that, experiment with making my own silver-based glues, silver-based epoxy, silver-based silicones, different types of silver adhesives that can make electrical circuitry stuff. So I would experiment with that. So anyways, people were saying to dissolve it in nitric acid and all this stuff, and I'm like, oh my gosh, where am I going to get nitric acid? And I don't know if I want to be dealing with all those fumes and blah blah blah. But I figured it out. So basically this is the way I think I should do it. Take the pellets, load them into a straw, or even if you got a bar, just load it into a tube so that by weight it's just trying to drop to the bottom of that tube. And then line up the bottom of that tube just above a file, a metal file. Connect that metal file to a sawzall or a jigsaw. Tape it onto the saw blade. Turn the power tool on. Duct tape the handle so it stays going, and have it going like that. And the silver will be dropping onto that file and getting filed down, and have a bowl collecting the powder in the bottom. You'll want to put a box over all this because powder is going to be floating in the air as well. You want to kind of try to contain all that, so keep it all trapped. Ideally a clear box so you can check up on it and look in there without breathing it in or letting that smoke into your house, which would get into your electrical circuitry of your computer and stuff like that and destroy your computer by short-circuiting things. Now, that powder that drops into the bowl will be a mixture of coarse powder and fine powder. But what if we just want the fine powder and the coarse stuff we got to get rid of? So we would put it into a strainer and shake it, and only the finest stuff would make it through. So that way we can get just the fine stuff of whatever fineness we want, depending on the filter size, we can allow more coarse stuff in with the fine or less coarse and only take the finest of the fine. So depending on the type of filter you get. So I will need to get a filter for this. Now, what do you do with all the coarse powder? You're not going to throw it away. The stuff that's too coarse for your needs and it's too late to use this by weight method to drop it down a tube and onto a file. You can't file powder. You file from a bar. Well, you take the coarser stuff now, melt it back down into a bar again, and then run it through your grinder setup again, making a new pile. Filter it out, get the finest stuff, and then melt down the stuff not fine enough into a bar again, and then run it through again. And you can do that over and over and over, melting down whatever wasn't fine enough, and eventually you'll have nothing but the finest of fine powders that you're going after. And I think that that is the ultimate solution. It will require me to make the grinder setup and to make a miniature foundry, a kiln and all that stuff, which I wanted to do anyways forever. So that'll be fun. I think I got all the materials actually to make this too, so that's kind of nice. So yeah, man, we're gonna do it up. No chemicals. I don't want to do this through electrolysis or acids. I don't want it to become a chemistry thing. I'm trying to stay away from chemistry. All the materials to do chemistry are very expensive, and you have to know what you're doing, and it can release toxic fumes. It's dangerous. And I just really don't want to open up that Pandora's box. See?
The large pieces was then milled in a coffee mill and sieved again.
0.1 millimeter mesh. Wake up. What is the diameter of a surgical needle? Press return. Syringe. Press return. .30 gauge, 2 millimeter. Press space. Press T. Press O. Press return. Okay, so the finest of fine surgical needles are 0.2 millimeters. And this guy is using a 0.1 millimeter filter to filter his zinc powder into a fine powder. That means his zinc powder could fit 2 side by side through this needle. Would it get jammed? I really don't know. Would that get jammed, guys? Or would they just go out one ball at a time-ish? Yeah, they could probably make it. Yeah, they'd be slippery in a glue form. And they'd funnel in, and since they're pretty much a ball, most likely, they'd form kind of a dust. They'd probably be kind of a ball shape. I think they would make their way through. Right, guys? When you file metal, what do the shavings look like? What shape are they? What shape are filed metal shavings? Press return. Okay, if it's shaped like that, we're in trouble. Well, these aren't filed. This is from a rotary grinder. That would get stuck in a surgical needle. But this kind of shavings is what we're going to have. I don't know. You know what? If the powder's only 0.1 millimeters, come on. It's not going to be long and skinny on one end. It's going to be pretty much in a square shape, right? So we should be okay. Square shape, I mean, I don't think they'll get stuck, no. I think a 0.1 millimeter filter will be a good size for a glue that's coming out of a fine surgical needle going onto a circuit board. Also, let's think about 0.1, 0.2. That's about the width, I think, yeah. 30 gauge wire can solder to the finest of pitch microcontrollers and processors. It's made for that. And that's the same thickness of these surgical needles, which works out great because we want the surgical needle to output a trace that's the same size as a 30 gauge Kynar wire, which is used to connect to a processor. We want our surgical needle to output the same width of traces as that, because we want our surgical needle to be able to draw on traces onto microprocessors. So this is actually going to work out perfectly. And 0.1 millimeters as a silver particle size is then going to work out perfect, because 0.24 millimeters is the size of a 30 gauge wire or a 30 gauge surgical needle. And so that means each silver particle, it's going to take 2.5 silver particles in width to create the thickness of a 30 gauge Kynar wire trace, which can attach to any fine pitched microcontroller. So under a microscope, I guess we would be able to see these little silver particles. Although some of them might even be smaller than 0.1 millimeters, but the filter would get rid of anything above that, which is all we care about. So the finer stuff would just be a bonus. It would go between the more coarse ones and connect them electrically. So we would want a mix of some even finer stuff as well, I imagine, and I think we'll naturally get that. If you even look at a random selection, stop listening. Here's a random selection of scrap metal shavings, and you can see that some are very fine and some are very big. They're not all uniform. So it stands to reason that some would be ultra fine, and that will actually play to our benefit. The ultra fine ones will be maybe 50 or 60% of it, and those will be go-betweens between some of the larger particles of silver and kind of be the glue that binds the larger pieces, even though by glue I mean just bridges, physical metal particle bridges, because the goal in a conductive glue is you have to have one piece of powder connected to another, physically touching each other. So having a lot of smaller ones mixed in will help to bridge it, making one solid string of silver particles that can actually carry current. So yeah, here's a picture of coarse and fine, and you can see a nice mixture of the two. So yeah, I think this is going to work, guys, but we need to buy a 0.1 millimeter filter bowl, like you can see in this video.
You can sieve the powder with finer mesh.
See that
but I
bowl?
don't have one, so I
That
stopped
bowl.
here. About 70% of zinc was chopped to particles finer than 0.1 millimeters. This powder is useful in chemistry and even work with pyrotechnics, and is much easier to ball mill if finer powder is needed.
Okay, I'm going to ask this guy a question, actually. Wake up. You say that you can ball mill to get even finer powder, period. I am looking to create very fine silver powder to create my own silver conductive epoxy for electronics projects, period. Can you ball mill silver? Question mark. Or is it only something you can do for soft metals? Question mark. I would imagine the balls in the ball mill must be harder than the metal you wish to chop into an even finer powder, right? Question mark. Stop listening. Wake up. Wake up. Is silver soft? Press return. Stop listening. Oh, silver's super soft! So it won't damage a ball mill. That's great! So we should make a ball mill! Okay, so that changes my plan entirely. I'm confident silver would work in a ball mill, considering it's softer than everything. It's extremely soft. So that means a stainless steel ball mill would make quick work of it, just wrecking it, and it wouldn't damage the balls and cause the balls to get somehow damaged. So we could ball mill this after we grind it. So now I have to research ball mill making. Gosh dang it. One thing leads to the next, I tell you. Good job asking that question, Escapeg. That helped me out. Okay. This type of bowl here, he said it only lets through 0.1 millimeter particles. You can even get it finer. I'm curious, what to even search for to buy something like that. Maybe I shouldn't be typing filter, maybe I should type in screen. Screen. Wake up. Screen bowl. Select bold. Choose one. Press return. Press return. Ooh. Stop listening. How the heck do you guys know this stuff? That's perfect. I want different size sifters. Wake up. Press space. Sifter. Sifter. 0.1 millimeter. Press return. Stop listening. Guys, we got it. We found 12 by 12 12 by 12 60 mesh 250 micron stainless steel filter. So this will filter it down to only stuff 250 microns. I did 250 micrometers, micron, which stands for micrometer. It's like a slang way to say it. 250 micrometers equals 0.25 millimeters. Now, 0.25 millimeters is 1/4 the size of the guy in the video who said he was just keeping the powder that was 0.1 millimeter and under. Oh, wait, that's too big. 0.25 millimeter. No, we wanted 0.1 millimeter and under. That's way too big. Okay, so that's not going to work. I thought we were good, but we're not good at all. I forgot it was 0.1, not 1. Alright, 150 micron. Oh, 100 micron is 0.1 millimeters. Wake up. 100. Press return. Stop listening. Okay, 0.1 millimeters, as we said, would fit too wide in a 30 gauge surgical needle. And 30 gauge Kynar wire is what you use to solder to the output pins of the tiniest of tiny chips for video game console modding. So that will work for the tiniest of traces that we're going to be drawing by hand. That is very, 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 very fine. I think that will actually work for creating our silver powder. Alright, so a nanometer is 1 times 10 to the negative 4 millimeters. So that looks like this. Let's see. 1, 2, 3, 4. Wait. 1 times 10 to the negative 4. 1, 2, 3, 4. 1, 2, 3, 4. Wait. Stop listening. Wake up. Microns. .30 gauge wire kynar is used for the finest traces on microprocessors. Stop listening. Okay, so 0.27 millimeters is 30 gauge. 30 gauge is the size you want for the smallest traces on a circuit board. So our particles of silver have to be well under 0.27 millimeters because you can't have silver particles the width of your trace. They have to be much smaller than the width of the finest trace you want to produce. And we want to be able to produce 30 gauge traces. So we want 0.1 or less, maybe 0.8 millimeters. Now, 0.8 would be right here. No, 0.8 would be right here. No, yeah, 0.8 would be right here. 0.1 millimeters. Now, I meant 0.08. 0.1 millimeters is the size mesh screen used in that video we were looking at to make the small fine powder zinc. He had a 0.1 millimeter mesh bowl. We would want 0.08 millimeters or less. Now, 0.1 millimeters is 100 micrometers, so we would want, like, let's say 100 or less, so it could be 90 or 80 micrometers. You can get all the way down to 25 micrometer meshes. I think that might be excessively small, because this would just be the largest of the powder. Also, a lot of smaller powder will get through. And all we care about is having a nice mixture of super small powder and maybe decently sized powder. And the super small will gap between the decent sized ones. I think the decent sized ones are still good to have because they're great conductors. It's like a solid chunk of silver for the electric to pass through. And then the really fine stuff will connect the bigger boys. So it'd be kind of like having a bunch of big chunks of copper wire with small solder joints, and the solder joints introduce some resistance, and the bigger chunks of copper wire are better conductors. So I feel like having the bigger chunks of silver powder will be a little place where there's no resistance for a moment, and then it turns back to resistance for the smaller pieces. So I have a feeling that having a combination of fine and bigger powder will be ideal. And by bigger, I still don't mean real big. I'm saying under 0.1 millimeters, which is about a third of the width of the trace we want. So if I'm looking at a trace under a microscope, the finest of traces, I'll actually be able to see the chunks of my silver in my glue that are up to a third the width of that trace. And these are very fine traces being looked at under a microscope, and you might be able to see a chunk of silver that's a third that wide. Now, if we have a 30 gauge, wake up. The finest syringe needles press delete are 30 gauge or 31 gauge, which is perfect for creating traces, exclamation mark. Okay, so anyway, stop listening. So anyways, yeah, I saw that video, Mike. Yeah, I'm thinking 3 or 4 silver particles wide should be a trace. I imagine they'd be in the shape of like a cube. Now, for them to pass through our surgical needle without getting bound up, we can't have them be each dust particle the same width as the surgical needle. Then they come out one at a time. That's ridiculously oversized. We want them to come out maybe, 3 or 4 particles wide fits the needle. Now this is a fine needle, so that's not saying, we're going to be putting out huge particles. The needle is the finest needle. We're talking ridiculously small under a microscope even. So that's nothing to be ashamed of. I think that's a good size. And also my concern would be, once we get 0.08, let's see, 0.08 millimeters, that's damn, 0.0001 millimeters is 100 nanometers. So it's be 0.000001 would be 1 nanometer. Damn, so they're like 1,000 times. Let's see, 100 nanometers is there times 10, 20, 30, wait, no, times 10 times 100 times 1,000 times 10,000. 10,000 nanometers is 0.1 millimeters. What the hell? So we're looking to create something that's like 80% the size of 0.1 millimeters. So let's say 9,500 nanometers wide is the size powder we're going to be using. And I read that some people created nanoscale particles of silver to create silver conductive glues. So their silver was 10,000 times smaller than mine. Maybe I need to make it, maybe I need to be making mine a little bit smaller, try to split the difference a little more. I'm not sure. But does that mean theirs would be more conductive than mine? I don't know. Like, does that matter if it's at nanoscale? Mine's certainly not nanoscale at all. You can see mine. You would be able to see mine with the naked eye. I guess the nanoscale would be invisible. Invisible. I could always create a ball mill and put my stuff into that and see what happens. I don't know. This filter crap is expensive. I'm not used to paying $20 for something. I don't feel comfortable with that. A dust particle. Wake up. A dust particle is between 2.5 micrometers and 10. Paste it. So if we used a 0.1 millimeter press return mesh filter for our silver dust, comma, it would be the size of 15 dust particles across in press return diameter. A HEPA filter is defined as a filter that filters out 99.97% of particles whose size is greater, press return, than 0.3 exclamation mark. So a particle that small would be 10 across to create, press return, a single particle of dust. And 15 particles of dust would be the size of our silver dust. particles. Press return. So our silver particles are still pretty huge in the scheme of things. Note that any particles that are too big after the filing process, as will be, press return, determined by sending all the filed dust through a filter, comma, will need to be, press return, broken down even smaller, period. This can be done via a ball mill because a ball mill, press return, has steel balls that are much harder than silver, which is a very soft metal, comma, press return. So they can easily crush the silver into tinier bits without themselves being damaged, press return, and mixing their components into the silver, taking away its purity, press semicolon, press return. I happen to know you can in fact ball mill metal, even though it makes no mention of that. Press return. On the ball mill Wikipedia page, because a guy on the Zinc, press return, powder making video, comma, here, colon, paste it, comma, said, press return, in the comments section that you can ball mill the powder further, and he, press return, seems to know his stuff. Aha! Stop listening. Check it out, boys. I didn't like that price point for that sifter, which was $10, and I've cracked it now. Now we're getting into the good stuff. This is my price range, $2.50. Now that I'll buy. But this is a nylon mesh. It is 200 mesh though. It's industrial filter cloth. I don't think there's necessarily a big problem with it being cloth, but nylon cloth, I don't know. I think I'd feel a little more comfortable working with metal. There we go. $2.59 for metal. Bam! This is 30 by 20 centimeters, which is 1 foot by 8 inches. That's plenty big enough. There we go. So that's how you got to search for it. You got to type in 200 mesh. That's what your search needs to be. You can't type in sifter or strainer or any of that other stuff. You won't get the results you want. You have to search it as mesh. 60 mesh is 250 microns, which is 0.25 millimeters. Which is 30 gauge. Wake up. Press percent of our needle. Space, hyphen, space, no good. Press 1, press 0. Press 5. Getting there. Press return. Paste it. Press return. Press return. Press 2. Press 0. Paste it. 2 microns. Press return. Press 7. Press 4. Press 0, press 7, press 4, press delete. Press 2, press 8. Decent! Exclamation mark. Press delete. Press Ctrl S. Press 5. I'll probably want to try 200 mesh and 250 mesh. $4. That's good because I get to try two different things for well under $5. That's my my sweet spot financially. Wake up. Press 5. Press 5. Press return. Press 5. Press 5. Press 5. Press 5. Stop listening. Okay, so 250 mesh is a coffee filter level. And that's half of 0.1 millimeters. And 0.1 millimeters 3 across is a 30 gauge Kynar wire. So this is half of that. So that's 1, 2, 3, 4, 5, 6. 6 of these across would equal the width of a trace. That's gotta be plenty small. 6 across is the width of a trace of the finest traces on a microprocessor. So that will not plug for sure our needle. I don't care if they're round or not, that's not going to plug it because they're so small and they've got the glue that can tumble around. Yeah, if you had something the full thickness of the inner diameter of your needle, that try to funnel several of those, and if they're not perfectly round pieces of metal, you'd picture that getting jammed. But this, no way. I don't think it'd get jammed at all. I think you'd be able to squeeze it right through. It's 6 across. Imagine trying to toss 6 marbles across a pipe that's six marbles wide. Those marbles aren't going to get stuck. They're going to dump right out, especially if they're mixed in a fluid. They'll just tumble and find their way. So, I think we're good. We'll be able to try the 2 different sizes. The 200 mesh and the 250 mesh. I feel very confident about this. How do they measure needle size? Needle size is measured in gauges. And the finest gauge syringe needles are 30 to 31 gauge. And it's the same thing as wire gauges in terms of width. Gauge means the same thing in both medical and in terms of electrical. And it just so happens by coincidence that Kynar wire, which is the kind of wire, 30 gauge Kynar wire is the kind of wire you use for soldering fine-pitched microprocessors for console modding, for example. So that's a really fine, that's like the finest size traces in all of electronics. Anything finer than that, and you're getting into the dies of a microchip, and nobody deals with that by hand or by machine. Like, that's the big companies dealing with dies and stuff. That's outside of what we're talking about here for doing circuits by hand. So yeah, we're good at 30 gauge, and 30 gauge is the width of a surgical needle, the fine surgical needles. So it's perfect that fine surgical needles just so happen to be the exact width that we wanted to begin with for the finest traces on a PCB. So it all is just coming together nicely. Note that 250 mesh is the size mesh used for coffee filters. Exclamation mark. Press return. Press 5. Stop listening. Heck. .250 mesh and 200 mesh are darn similar if you ask me, actually. This is kind of too small. I prefer the 200 mesh size. Unless if I can get it bigger. That's too small for me. Oh wow, and if you buy it 250 mesh at 6 inch by 6 inch, it goes up to $6. That's outside of my price range. Okay, so the sweet spot is if you buy 200 mesh. That's $2.59. I'm just gonna have to go with that. I like that price point, and I think it's fine. Why buy two meshes that are only 3% difference in the size of particles? Either it's gonna work or it's not. That's not gonna make a difference. So we'll just go ahead and go with the 200 mesh, and I'll show you guys that. That's here. It's just a lot. It's just an excellent price point. $2.59. I can do that all day. Okay, so we're gonna go ahead and buy that. It comes in 1 foot by 8 inches, so plenty big. We can just dump our powder in and shake it around in there, holding it with 2 hands or whatever. But we're gonna want to do this all in the garage so we don't get this silver powder all over stuff in the house. In fact, we'll probably want to do it in a vacuum chamber of some sort. But yeah, I feel comfortable with that. That's very, very fine. We should be okay. I already have a vacuum chamber, guys. What do you think that is that I've been using all this time? That's a vacuum chamber. And it works. 100%. I can do any of this stuff in that. It goes through HEPA filters. And those HEPA filters, whether they failed or not, get pumped out to the outdoors as well. I mean, it's completely safe. .3 millimeters is 30 gauge. So this looked to be about 0.4. So maybe like a 26 gauge. So it's not the finest. But it's like $4 to buy something finer. So I'm just going to go with that. If I get to a situation where I need even finer, I realized a workaround. We could make our traces at the 0.5 millimeter level, but when we need to make them even smaller, we can just use the very tip of the needle, the sharp part, stick it into our glue and just drag it, forming a razor sharp little line leading to the output pin of the processor. That way it would be like, the trace would be like this, and it would just taper down until it comes to a point and hits that processor like that. So in that way we can get around the fact that the needle I already own is a little bit too big. But for the most part, traces you would want them to be a little wider because it'd be lower resistance, more surface area for the electric to travel along. For example, when you need to run a lot of current through a trace on a circuit board, you make the trace a lot wider. So this will allow more current to go through and less resistance. That's a good thing, to have it a little on the wider side. And like I said, the only time on a circuit board we'd have any issue with that is if we're dealing with really fine-pitched microprocessors, and for that we could just draw the glue in by hand with the very razor-sharp tip of the needle. We can just draw it, dip it and draw it like we're drawing with the toothpick dipped in paint for the accuracy. Except this is even sharper than the toothpick. And we'd have it under, 200 times magnification with our microscope webcam setup, and I'll be able to see what I'm doing really well, and I can just draw perfect little traces that go onto the microprocessors. So we'll be good with our existing equipment. We don't need to buy a 30 gauge needle or anything. So that'll save us some money right there. We'll stick with the needle we already have. Alright, so we bought the mesh. Now we just need to consider if we want to buy the materials required to make a ball mill. To my understanding, we should be fine with what, like a Folgers can? Let's see. Well, we better check it out. We for sure gotta buy the balls. Wake up. DIY ball mill. Press return. Okay, I like this. PVC pipe ball mill.
Today, I'm going to show you how to turn a whole bunch
totally doable.
of PVC
Genius.
into an epic ball mill jar. Great for crushing chemicals, making black powder.
Perfect. I have that for free.
Really, whatever you want to do with this. You can even throw card parts in here, clean them up with the correct media. This is an absolutely great tool to have in your home shop.
Well, I want to hear what he uses it for.
A PVC pipe into an epic ball mill jar. Great for crushing chemicals, making black powder, cleaning brass.
Great for crushing chemicals, making black powder, cleaning brass.
Making aluminum powder, really whatever you want to do with this.
Making aluminum powder! Making aluminum powder! Okay, so it can be used to crush metal into finer metal, provided that... Stop listening. Provided that the metal you're wishing to crush is softer than the balls that are doing the crushing. Otherwise, the balls would break down too, causing whatever metal you're trying to crush to become mixed with the steel balls, and then it's not going to be that metal anymore. It's going to be a hybrid of two different metals mixed together. And that's not what we want. We've got to have pure metal still. So let me take a note of that.
Obviously, you need a ball mill itself. Now these are really easy to cobble together. It doesn't have to be anything fancy. 2-inch pulley up here, 1725 third horsepower motor. That's just an old junker I had laying around. A 6.5-inch pulley up here on just some extruded aluminum rod. A couple pillow block bearings, and Bob's your uncle. Done. The jar is honestly probably the harder part to build. You can buy them. I have a couple, crappy Harbor Freight type ball mill jars over there. They really don't last long. They're not easy to use. They're really just a pain in the ass. So what we're going to do is build one much, much better. So the parts you're going to want for this project, you're going to want a section of 4-inch PVC pipe, schedule 40, section of 3-inch PVC pipe, schedule 40. This is just some scrap 4-inch section I had laying around. I'm going to use this to put in the lifter ribs. 4-inch PVC end cap. You want to get the type that doesn't have a big ridge on there. That'll kind of mess up where it's sitting on the roller. What the hell is this thing called? A flush bushing. Alright, so get yourself a flush bushing. So what this does is reduces the pipe diameter. This sits inside of the 4-inch pipe. Or, inside the coupler. Like so. Obviously, get yourself a coupler too. And then, so 4-inch to 3-inch flush bushing. And then you're also going to need a 3-inch, what the hell is this thing called? Drain sewer plug, or cover, whatever this is. Just a quick cap, easy to use. Get rid of that. And that's what you need. Tools you're going to need are basically just a chop saw and a bandsaw to put in the lifters. And a shit ton of clamps. Guys, you can never get enough clamps. Definitely stock up on your clamps here. Alright, we're over at the saw. Definitely a little large on the capacity side for this little chop saw, but it'll do. We have the 4-inch PVC marked for a 6-inch section cut, and then our 3-inch PVC marked for a 3¼ inch second cut. I'm going to clean your grinder, polish your grinder. You can do this all I like. Roughly get the masses. It's not going to be perfect. We're going to fix all the filing anyway. This is where adding the fence would be really nice. Alright, I'm just going to clean this out of the file. Here's the course around. Oh, nasty. So, good place. So, this side is really clean. Over here to the left. Right. Yeah, everything's going to have to do this part, but
down for a second here. This stuff does get everywhere, and it's not a hurt product, it gets everywhere. Not a big deal. Then we're just going to use some cement on there. We're in position here. Alright, hopefully we got it. Get the on there real quick. You see, roughly mark out, yeah, 90 degrees where we want you to go. Also, not a critical thing, as long as you get the heat in there, nice and roll around, you're going to function just fine. 24 hours, probably sniff it over still. But we have a good strong bond there, so you don't have to worry about it on the part. See the primary to the next pretty good stuff. Please not affect performance at all. So we'll probably disappear after the first couple rounds. There you go. There's liquid there, key. Nice coating of cement in there. And bottom we go. That's on there. Now you can see exactly what's happening. Let me grab some longer to show. So basically, as this is working around, force everything to come up on the side, constantly fall and tumble and crash on themselves. And whenever you add in there, whether it's pins, for good. That's purple enough. Let's get this one purpled up.
Could you hook it up to a drill? Yeah, but I have motors. I might as well use them. I've been buying tons of motors for my robot.
Alright. Looking good.
They're only like $5.
Full seating. Like to give a little tap. Make sure everything's in place, nice and snug. Now repeat. It's amazing how strong this bond is between PVC joints. It's just absolutely incredible. Don't be afraid to really slather it on there. Not in that fashion though, if that's what you're thinking. Alright. That's looking pretty. Good enough to eat off. We're out of. And that is a complete ball mill jar. Beautiful. So in several upcoming videos, I'm going to be using this ball mill, or ball mill jar, rotary tumbler jar, whatever you want to call it, to make quite a few cool things. We're going to do aluminum powder, whether you want to use that for tannerite or flash or whatever it might be. We're going to clean some brass up with it. So if you want to see more cool shit being made, don't forget to subscribe, thumbs up, leave a comment, let me know what you think, and let me know if you're going to build your own. Have a great day, guys. What's going on, guys? Welcome back to the shop. Today we are going to be turning some Walmart brand aluminum foil into high grade tannerite flash powder grade aluminum powder. Using a lot of balls. This process does take a lot of balls, so better have a good stack of balls. Obviously you need some, this is just a great value brand aluminum foil. Probably shouldn't have gotten the heavy duty. You can see here, this is a heavy duty, which means it's a little bit thicker. It would actually probably be better to go with a regular grade aluminum foil, just because it's a little bit thinner, easier for the balls to crush up. Blowtorch, just to help brittle up the aluminum. And you're obviously going to need the ball mill jar that we built in this video. So, excuse the ringing. So you can see the lifters in there. They're designed to pick up the balls and drop them on the aluminum constantly as the jar is rotating in the ball mill. So, let's get started. We're just going to blowtorch our aluminum. You can see I already shredded some up. You can probably run it through a paper shredder. That'll probably make life a lot easier. And for the balls, one thing. These are high grade nickel chromium alloy balls. And I'm using a mixture of half-inch balls, and these are quarter-inch balls. And what that mix is going to do is going to allow it to basically process the aluminum faster and break it down into powder at a faster rate, so that we can, you know.
Its results, comma, and we have filtered out the finest particles through. Press return. Our 200 mesh filter, comma, press return. Filter, comma, we take the remaining overly large particles and put them into our press return homemade ball mill, semicolon. This will be made using 4-inch PVC pipe with 4 longitudinal press return PVC flutes designed to kick the balls around during the spinning process, semicolon.
Situation. So we'll see. The cool thing here is the aluminum will oxidize pretty rapidly, especially once it gets into smaller particle size. And what that's going to actually do is create aluminum oxide, commonly used in sandpaper. Cheap sandpaper that's crappy by the dollar store, but still it's a good abrasive, so it's actually going to help abrade itself, which is kind of neat. Yes, it is hot, but it really just doesn't have the mass to burn it. You see how this stuff gets real brittle and kind of crummy. So we're probably going to need a lot more aluminum powder to this. This is not going to be enough to make much powder. Alright, having to play all this, some powder gets really enough. So let's start starting all no pools. You can also run this stuff through a blender. That'll help get the initial knockdown particle size. Saves a little bit of time, but this is kind of the set and forget method. Break out the chrome steel ball, bearing balls. 1/2 inch, 1/4 inch. Okay, let's get that on the mill. And we're
Stop listening. He just gave away a key piece of information. He called them He called them chrome steel bearing balls. Before he called them nickel chromium balls. I think that the second way he described it's probably more accurate as far as how to actually find these balls and purchase them in an inexpensive fashion.
set up because I used to use this for making.
You're sorry. It'll be so much easier just to screw the lid on than to deal with that rubber lid with a screwdriver. I think it will be faster, but yeah, I don't think any buts. I think it really will be faster, truly.
Black color to color in. So it's been about 15 minutes, which is not nearly enough time to really do anything with the aluminum.
What's going on, guys? Welcome back to the shop today. A 6.5 inch pulley up here on just some mill itself. Now these are really easy to cobble together. It doesn't have to be anything fancy, you know, a 2-inch pulley up here, 1725 3rd horsepower motor. That's just an old junker I had laying around. A 6.5 inch pulley up here on just some extruded aluminum rod. A couple pillow block bearings. On just some extruded aluminum rod, a couple pillow block bearings, and Bob's your uncle. Done.
To prevent too much rubbing from happening, open parentheses, optional, close parentheses, semicolon, press return. Could probably also just have them grind away at whatever. Space hyphen space. Undo. Hyphen. For example, they, comma, could end in a steel rod that goes through a nylon bushing and spins within that, press return, without there being too much friction, semicolon. Anyways, comma, we would need a motor that, press return, would connect to only one of the two parallel tubes and turn that, which would be, press return, enough to spin the pipe, which will sit on top of the two parallel tubes, semicolon. Note that, press return, there will be slippage, and so the motorized tube that is causing the pipe to turn, press return, will actually be spinning much faster than the pipe, which is okay, press comma, because, press return, the pipe is actually better off slow-ish, press delete, press L, press Y, turning to prevent the balls from all, press return, sticking to the outer perimeter of the PVC pipe due to the excessive amount, press return, of centrifugal force that would be created if it were to spin at extreme, press return, high speeds, semicolon. In fact, comma, one pipe may even be better off having a large pulley on one end, press return, that the motor attaches to, which will cause it to spin slower than the motor is spinning. Press return, semicolon. Also, the spinning longitudinal tube is to be slick surfaced because, press return, if it were grippy, comma, it wouldn't have enough slippage and the PVC pipe, press return, would spin too fast, approaching a 1-to-1 ratio of spin speed with it, semicolon. Press Ctrl S. Stop listening. Wake up. Press return. You can use a hand drill that is geared down so that it has a slower speed, and press return. More torque to directly turn one of the two longitudinal tubes. And this, press return. Because it is down geared, would be better than a raw motor turning it, which has, press return, no down gearing, and you would have to create your own gear system via pulleys. Press return, which adds unneeded complexity, semicolon. So it is actually better in this case to use, press return, a slowish hand drill, semicolon. Press Ctrl S. Stop listening. Alright, so I answered your question, Mike, through my actual note taking. Yes. The way he's doing this is idiotic. He has a drill designed to have tremendous power. Look at the size of it. Not necessary. He can use a drill 1/50th that size. It doesn't need to have tremendous torque. It doesn't need to have tremendous power. This is a waste of power. Unless if he just wanted to get rid of this motor for whatever reason. He could use a tiny motor and it would still turn this pipe, which has a lot of slippage. It would easily be able to turn it, even with a motor this small. So he could use like a 330 motor or even a 270 motor easily. But he's using a gigantic 1 horsepower AC motor for no reason. But I'm not going to hate on him. He might not know better. I don't know. And he's also slowing down the motor through this pulley system. So the motor's output shaft is smaller than this output shaft, which means it turns 6 times to every 3 times this turns. So that slows it down, increasing the torque, which is again not necessary. He's already got way more torque. But the whole point of the pulley is to slow down the motor. And then this output shaft is slick so that it will have slippage on the PVC pipe he's going to lay here, so that the PVC pipe won't spin at the same speed as this pipe. If he wanted the PVC pipe to spin faster, he'd actually use a smaller pulley wheel here than the motor has. Maybe even put a big wheel over this motor, and then it would go way faster. And then for the pipe, he would put some no-slip rubber or something, and then the PVC pipe he lays on it will spin much, much faster because it won't have as much slippage. But he doesn't do any of those things. This being slick, and this being bigger, and this being smaller, all point to him trying to slow down what this motor's outputting. He could also slow it down through pulse width modulation with the microcontroller and a series of relays to turn on and off the AC power to it, but that's getting complicated, I guess. So anyways, yeah, we'll just connect probably directly a pipe here to our cordless drill. We could have this pipe just be some steel rod that will fit in the cordless drill. Or rather, we would have steel rod center tapped into here, coming out the end of this pipe, and then put our drill in it, and then duct tape the drill handle, and then this will just turn this pipe. We won't need this big pulley, we won't need a big motor, we won't need a belt. We'll just direct drive it off a drill, which will just build a little place for it to lay here. And we'll just stick 2 pipes side by side. He said this is an aluminum pipe. I've never seen a black aluminum pipe. That looks like a steel pipe to me. So I think he's wrong there. I think that is a steel black pipe, just like the one I use for my CNC machine. So yeah, I'll probably do it that way. I just want to see the rest of this one.
We're going to add a little bit more, and I forgot to add charcoal, so we're going to add a little bit of charcoal.
I don't agree with adding charcoal though, because that's going to make your resulting metal unpure. It's going to be a charcoal aluminum mixture. I would want pure aluminum or pure silver, whatever. I wouldn't want charcoal mixed in, so I wouldn't do that. I disagree with that decision.
It's pretty dark in there. Get a flashlight. Flashlight required. As you can see, it's breaking it up pretty nicely already. Surprisingly well. I mean,
How is he going to
even
filter out the charcoal
using
after? I wouldn't
charcoal
trust that. That'd be a mess trying to filter out that charcoal.
I guess you see the walls are already dark here. I don't know if you can see it on camera, but it is shiny. So,
That would create graphite, which is electrically conductive, or graphene. And they make graphite electrically conductive wire glue instead of silver, but it's far less electrically conductive than silver. It would have like 5 ohms per centimeter instead of 0.0005 ohms per centimeter that silver can offer. So I would not want to introduce that. It would increase the resistance of my ending glue.
so yeah, we'll get the window started. So that's more what we'll do it. And what I started doing is just rolling out big sheets of the aluminum. And just one more sheet, just to make the aluminum brittle, go outside there a little bit. So yeah, just right here. That way.
I think heating it to make it brittle is, well, it doesn't look like too much work, but I think it's probably unnecessary. He said he wants to do set it and forget it. He could probably just stick the aluminum in a blender to start things off, which we've seen in other videos. That works really well. And then dump it in the ball mill right afterward. But if the ball mill really worked, I honestly think he wouldn't have to do any of that. He could just put it in there full. Wouldn't it eventually rip it up anyways? Just leave it in for an extra day. Who cares? Save a little bit of time. But whatever. He can do what he wants. Definitely would speed it up to be brittle, but the whole point of a ball mill is it's gonna create powder while you're gone. You can leave it on for a week. It doesn't matter. If you're in a big hurry, I could see trying to make it more brittle just to speed it up by an hour. I don't know. Wow, look at it. Dang, that's fine. Woohoo! That is so fun. He should be working in a vacuum chamber for that.
We could easily do already. Yeah, that's a pretty reactive powder already. That's impressive. 24 hours of milling. That jar is pretty damn efficient. So let's let it back in, let it go for another 24, and then we'll whip up some thermite. We could easily do already at this point. This is plenty fine for thermite. But flash powder is probably not quite there yet. So we'll give it another 24 hours. Get down to that nice.
Wake up. What is flash powder? Press return. Why does it have a picture of a bomb next to me? Oh my gosh, man. I'm even not having any materials right now. I'm only doing the research phase right now.
Where you know it's super fine aluminum powder. And at that point, we'll give it a test. Sorry for the horrendous noise, guys, but just want to go over the power consumption here.
I'm not even planning to make flash powder or anything like that. Anything that could blow up, I'm not interested in. I plan to make my own batteries. I have a lot of things I'm planning to make, but I'm not interested in making things that are shiny and sparkly. I'm not into fireworks anymore, and I remember reading about or hearing about some guy that got arrested for making fireworks illegally in his basement, and he probably sold them for a lot of money. I thought that sounds fun, but this guy went to jail. I don't want a felony.
This is about 194 kilowatts, or 194 watts.
They don't mess around. They sent the bomb squad to his house. That'd be embarrassing.
Anyway, so that's my total consumption since I plugged this thing in, just to see roundabout what it would produce. So, back at the test here. See, I did a little calculation there. I know earlier I was talking about the cost, not really being cost effective. Well, it turns out, basing this on 40 hours in milling to get down to your, super fine aluminum powder, figuring it's using 195 watts. That's actually, when it first starts out, once the motor heats up, it actually drops down into the 180s. But figuring, 40 hours, we're looking at 7.8 kilowatts. And around here, the electric is about 12 cents per kilowatt.
Ha!
So, all this time
This guy's talking about efficiency. Then why is he using an enormous motor that's spinning at probably 200 times the speed of the pipe he is actually trying to spin, and then gearing it down? He could use a motor 1/10 that size.
running it, it's actually been about 94 cents, which actually isn't too bad for the aluminum powder it produces. Stuff.
He could be saving way more on electric.
So it's still not probably very, cost efficient, but it's doable. If this is how you need to make your aluminum powder, you're not missing out a whole lot. It's not all going to be super fine. Slap it. Most of it out there. So let's use the strainer to separate the steel media. This is some good aluminum powder. But there's definitely some bigger flakes still left in there. That's all right. It's not going to really affect performance. But, hell, for 94 cents, that is some great aluminum powder. Let's mix up a little bit of thermite and a little bit of flash powder and see how it works for each of them. Just want to get an idea here of how much we actually made for that 94 cents. See if it is cost comparable. Lost a little bit there. Another gram or so.
Yeah, I know I get the electric for free. I'm just saying he's the one doing the math, seeing how much it's costing him and determining whether it's cost efficient or not. And I don't think that's fair when he's using a ginormous motor that's not required. If he's really concerned about it enough to do math on paper, he should be using a much smaller motor. He'd get the same results.
Pretty fun stuff with 18 grams of aluminum powder. And, if I spent more time, crushed up, or cut up more aluminum, easily could make double, triple, quadruple that in the same amount of time. So here we got some of the thermite mix. The portions definitely are not correct, judging from what the first one looked like. It's definitely a thermite reaction.
Oh my!
Pretty cool. Alright, now let's try mixing up some flash powder, see how that works. So here we have...
Oh, I thought thermite can, burn through a bank vault. That thing didn't burn long enough to burn through anything. I don't get it. That didn't seem very threatening to me.
Be the whole gram. Just enough to get an idea of how it burns.
What are we making today? We're not making anything. I'm only researching how to make silver powder for my silver electrically conductive glue project.
Wow. That is good flash powder.
That was pretty cool.
Was just rudely interrupted by my smoke detector. Far away.
Why are you guys calling the FBI? I haven't done anything.
That is good flash powder. So there you have it, guys. That is literally all you need to make. Was just rudely interrupted by my smoke detector. But so that really is the first major test of our ball mill jar.
Come on! Don't report me. I haven't done anything bad.
Just, a ball mill, a good jar, and some ball bearing balls media. Pretty impressive. I'm definitely surprised with how well that performed. That's the kind of dud that I felt heard from the video. If you liked it, please leave a thumbs up and consider subscribing because I have a lot more cool projects coming up.
All right, now it's taking action. I'm not a researcher, guys. I research enough to do the job. I'm a doer. I'm not making some toys. I don't play games. I'm making silver conductive ink. Wake up. 1/2-inch steel bearing balls. we have here 5mm stainless steel bearing balls. And that's half an inch. 50 of them for $1. What a deal. For $1.50. Wow. That's just incredible. Okay, here's why I don't want to buy silver highly conductive electrical paint. It costs $12 for 1 gram. No, it was $16 for 1 gram from Atom Adhesives. And 1 gram of silver, which is about 90% of the weight involved, not the glue's weight. 1 gram of silver, the market value of that is 41 cents. So they're charging $16 for something that should only cost 41 cents plus the cost of glue, which might be 5 cents, and something so tiny. Alright, so that would be the equivalent of them charging basically over $15 for enough glue to fill up barely like half of my fingertip for $15. I'm not going to pay it. I refuse to support those scammers. So that's why I'm going to buy my own silver, mix it up with Elmer's school glue that I've had since 4th grade, and I've got the same product they have for a fraction of the cost. And I can produce as much of it as I want. And I don't have to be stingy with it. I can use plenty of it, and I can use it for all my circuitry making. Why is there an FBI submission link? Yeah, everything I do on the cheap. So that's why I'm not trying to buy silver epoxy, because it's extremely overpriced. And the only reason for that is because not many people do it that way. Most people buy jumper wiring and breadboards and stuff to do electronics projects. Nobody really uses electrically conductive glue to draw the connections out between components by hand through a needle. This is radical thinking here. So in other words, I'm a radical. I don't mean radical like that. I mean radical outside the box thinker. So here we go. We're just going to get the 20. $3. I'm not willing to spend $6. That's too much money. What do I look like? Bill Gates? Yeah, the robot would be an exact replica of myself. $10mm. Wake up. Wake up. 10mm steel bearing balls. Press space. Press X. Press 1. Press 9. $3.13. Press delete. Select all. Press Ctrl C. Close window. Press return. Paste it. Evidence of what? Undo. Stop listening. I was just trying to visualize how half-inch balls times 20 would look. I think it would fill my hands pretty much. It would fill this. And I'm picturing that inside a 4-inch diameter PVC pipe, and whether that would be enough to like be a substantial enough amount to grind up everything. We're going to need to make the pipe kind of smaller area since we didn't buy probably enough balls. We might make the length of the pipe a little shorter. Alright, so we've already got the PVC parts. We've already got the motors. Well, we're going to use a drill. We've already got the tumbler pipes. Now we have the ball mills. We already bought the filter. We got everything. So once everything gets shipped in, we just had to buy the 2 different type of bearing balls and the pipe, and we're good. So once this all comes in, we'll be able to do it. And I already ordered the silver, and we're going to use PVA glue. I ordered several other types of glue to run experiments with. So we're good. And that concludes all the research and everything needed to make silver electrically conductive epoxy / paint / ink, however you want to describe it. That concludes our research and all of our processing and note-taking and ordering of parts. So we are now ready. If you guys want to have some idea of some of the machines I'll be building, I'm going to be building a polyethylene foam making machine, a textile mill, recycling machines for plastic recycling, artificial silicone skin, a welder, a zinc plating and electrolysis machines. I'll be making a foundry furnace for casting iron, steel, aluminum, etc. parts. I'll be making a metal 3D printer that 3D prints in metal. I already made a plastic 3D printer. I'll be making an all-in-one CNC machine that will be able to route, mill, laser cut, sew, paint, and 3D print in a large form factor. I'll be making my own lithium batteries. I'll be recycling water bottles to create polyester fabric. I'm going to be creating a robot army. I'm going to be creating drones. I'm going to be creating a robot dog. I'm going to be creating a robot arm that lives inside my car. And when I pull up to a gas station, it will automatically deploy and pump my gas, including paying at the pump and everything. It's going to have a credit card hidden inside its compartment with it. I had to do my due diligence, and turns out you can buy silver powder pure, already ground to a powder, for approximately the same price as buying silver bullion and grinding it into powder yourself. But not all sellers do this. I just found a special seller whose price is approximately $1 per gram. Like it's like $1.07 per gram, and I was able to find $1 per gram buying bullion. Now, that's not to say I can't get some savings if I buy bullion in large bulk quantities, but to save 10 cents per gram isn't worth making my own powder. It's not worth extra work. So I'm just going to buy this powder, 27 bucks, and mix it in with different types of glues, find out a formulation that works, and boom, we're done. So that's going to be a huge time saver. I am excited to make metal powders, but we don't not get to enjoy making our own metal powders because we still need to make zinc powder. Although I might be able to buy zinc powder pre-made as well. I should probably look into that too. Maybe we shouldn't be making metal powders if you can just buy it for the same amount as the raw metal. I mean, this seller is special that they're doing it for such a great price. I'm telling you, it's the only seller on eBay doing it at such a great price. Most of the sellers do not. I just happen to find one seller that has great prices. So I'm going to have to jump on that. It's too good of an opportunity.